Next, we're going to use the EAV tool to estimate the actual velocity from radial velocity in the radar data, ground relative, with an estimated wind direction. So to start out, let's clear our display, and under the KCRI menu, let's go down and load 0.5 CV. Now we're going to zoom in to this supercell close to the radar. Normally we like to use the estimated actual velocity tool on bow echo environments where we have very large 2D structures that we have a high confidence in estimating wind direction from echo geometry as well as coverage. If we do have one report, that we can be more confident that that report applies over a larger area, as typically happens with large damaging wind events. So we don't have that in this case, but we can still use it to demonstrate at least one area where we might have some constant wind direction over a fairly broad area, and that's the inflow for this storm. Let's go ahead and, using the left arrow, go ahead and step backward in time to 2311, or 2317, 14, 11. So we can see there's some consistency in this very strong inflow ahead of this supercell. And with the radar being here, these are strong outbound velocities. Let's go to 2311, zoom in on the storm, and then sample out some of these values, these very high values. We see we've got a 69 there, and I think that's the heart of it, 71 knots. So about 80 mile an hour winds, at least the radial direction is kind of from the east-southeast. But let's say we had some spotters that were out there ahead of this saying the wind direction at the surface is from the east or east-northeast, and they can look up and see the cloud base is also screaming in from that direction as well. And so maybe there's a very deep layer of strong easterly winds here, and the radar is only measuring a component of that. So let's go under the Tools menu, and under the Estimated Actual Velocity, we can load this using our right-click tip again, where we can right-click on the gate that we want this to start off at, and then we'll right-click over here and maybe make an east-west wind with the orientation of this bar being aligned along the wind direction that we're estimating. So if we're given the information that it's an east-west oriented wind direction at the surface and that extends up the cloud base, which might be at this height, we're at 1900 feet above ground level, then this might be a context that would be reasonable in this circumstance. If we do the Control-I option to get the imaging properties up, another tip that I like to do in these kind of circumstances is just fade away the background image data a little bit so we can see the output from the icon overlays. So what was a value of 70 knots to begin with has increased to 78 knots because, again, this east-west wind, this from east to west wind, the radar would only be measuring a component of that, and so the velocity is stronger than the radial velocity it's sampling. So if we move this aligned along the radial, then we see we get the actual radial velocity, 71 knots, that we were looking at. If it's an east-west wind, we see it's 83 knots. If we go the other direction, the same amount, we can see that it's going to be very similar there on either side of that radial velocity measurement. So if we go to really extreme angles, we'll see that we get these double tildes when the calculations blow up to really unreasonable values, and it's basically meaningless because once you get closer to these extreme values, the radar can't sample the velocities when it's perpendicular to the radar beam, and then any sort of slight differences cause this equation to blow up, and it really isn't usable anywhere where you've got double tildes. So you can just get a sense that if you were thinking that the wind directions were more from the east in this case, you had some reason to believe that, then you could infer that these 70 knot or 80 mile an hour winds that are being sampled at 1800 feet might actually be more like 80 knots and 90 miles an hour in actuality, and then it might even be stronger than what you're anticipating, or at least what the radar data is showing. So this gives you a sense for how the estimated actual velocity tool provides some more information about the component of the wind being sampled if you have an accurate wind direction. But you have to have a really accurate wind direction to use this tool effectively.